Joe, thank you very much for the introduction. So as Joe had mentioned, we're going to be talking today a little bit about the Metal X system from Markforged. If you were with us last week for our desktop composite series, we brought in our file and we chose a placement and went ahead and printed that out. The beginning steps here will be similar. So what I'm going to go is to my import STL, choose my file, and we're going to be working with a bottle opener this week. So here is what we'll be printing. And the first thing we want to do when working in the Metal X system is to make sure that we come over here to our printer type and choose the appropriate printer. So we're going to be working with the Metal X. We'll be using a Sinter 1 for this. And the material we'll be using is 17-4 stainless steel. Other options we have with the Metal X are Inconel 625, the H13 tool steel, A2 and D2 tool steels, as well as copper. So let's go to our settings tab and see what kind of options we have here. So similar to our desktop model, we can go ahead and choose our layer thickness. So here we have 0.125 and currently being tested, we have a 0.050 layer thickness for some real fine detail. We'll stick with metric units. Our scale is currently going to be 1, and we want our part to be set up for sinter stability. Leak resistance does not apply to this part, but if we were making a part that needed to be leak resistant, that is a box we could check on. And you see that it does give a warning here. And it says the leak resistance setting can prevent leaking for certain geometries. It makes the layer lines more prominent and reduces the surface quality. So that's just something to keep in mind if you're going to be creating a leak resistant part. We will not need any support structure on this part that we'll be printing, and we are going to use a raft. So moving to our infill settings, you can see that on the desktop model that we talked about last week, we had options for our infill percentages. When we move to the metal, we can choose our pattern, but we do not have an option for percentage of infill. So we've got our triangular, our gyroid fill, and also solid. So a couple things we can look at is if we go ahead and choose our triangular fill and save our part, we can take a look at the internal view so we can see what the structure is going to be on the inside of our part. And again, by using the slider bar at the base of our screen here, it lets us scroll through our build. So that's going to be our raft, getting to our part. And we can see here we've got this infill pattern, which we chose as triangular. And as we get to the top, you see your solid surface there. One other thing that's kind of neat is we can also do an exposed infill, which is also in the testing phases. And what that's going to do is if we go here, we click on our exposed infill, it generates the part without any roof or floor layers. Can affect the printability of certain geometries such as internal holes and shallow angle overhangs. Rafts are recommended, but let's go ahead and just kind of take a look at this and see how this looks when we look at our internal view. So when we take a look here and we build our part, you can see as our part starts, this is our infill. And when this is separated from our raft, we will see that infill. So something that can kind of add a unique feature to some parts. And here's our top layer. Again, no roof. So then you can also see your infill. We have control over our wall layers as well. And when we're looking at the Metal X, we do notice that we have quite a few less choices to make as we did with composites. Again, we can take a look at the overview of our part, and it's showing a 3-hour and 45-minute print time, wash time of 4 hours, a dry time of 1 hour and 30 minutes, printed mass, final part mass of our volumes, and our material cost. So let's go ahead and we'll send this off to print. Let's see what our warning here. And we're going to go ahead and change our infill. Triangular, good. Okay, stick with all this. And this is our build. And we'll go ahead and print right to our Metal X. So that is off to our Metal X. A couple other functions that we have here in Eiger when dealing with our metal system is we have to take into consideration that this is a 3-part process in that it's going to have to be printed, washed, and sintered. So here under my activity monitor, it allows me to track all of this information. So after my part has been printed, so we're going to be using this cap opener, I can come into my wash jobs and I can add from the library the part that I have just printed. This allows me to track it through our production. So our part is ready to wash. We can go ahead, start wash. It's telling us that we have a 4-hour and 0-minute wash time. And there we go. We see it starting our timer, counting down, so we're able to track our wash cycles. I'm going to go ahead and kind of fast forward through the wash cycle here, just to show you what we can do next. Actually, what we'll do is we'll put on our initial mass from the start, which we would take after it is printed. So 68.67. And we'll go ahead and we'll mark this as drying now. And you will see it jump from the wash section down to our drying section. Once we're done drying, after 1 hour and 29 minutes, we can go ahead, mark as done drying, and enter our final mass. Using our initial and end mass, we can calculate the total mass loss, and we have to reach a certain percentage for each material that we use. So later on, I'm going to show you how to use these two numbers to calculate whether the part has been properly washed and is ready for a sinter, or if it needs to be rewashed. One other thing I do want to point out as well is when we look at our part here, there's one warning that really is specific to the Metal X. And if we look under our settings, and I'm just going to really blow this part up so we can get some errors here. And the first error that I want to address here is, let's see here, this model configuration does not fit in the sinter one. So that's something to keep in consideration when you're creating your parts. We can do external sintering as well as sinter 2, which each one of those will have a larger volume than the sinter 1. So it's just something to keep in mind. If Eiger is giving you an error or a warning, to take a look at it and see if it's something that impacts your current print. Another thing we can do, since we have a sinter job running now, we can monitor our sinter through Eiger. So this is showing our furnace temp, our total runs, what our inert gas pressures are at, and how much gas we have. It also lets us monitor our supply life for exhaust and supply filters. You can see here, our sinter run is in progress. We're in the debinding status, and we have 1 day and 2 hours left for our run to be complete. So at this point, I would like to switch over to some shots of us printing, washing, and sintering our parts. We'll see you over there. So here we are at our Metal X setup, and as you can see, it's comprised of three main components: the printer, the wash, and the sintering oven. So our part is completed printing, so we'll go ahead and remove it from the build chamber. And this here is what we call a green part. This is our 17-4 stainless steel. And what we're going to go ahead and do now is take a weight of our part so we can note the initial mass. Once we get our initial mass, we'll go ahead and record it on the back of our part. At this time, we're going to go ahead and place it in our parts basket to begin the wash process. Now, if you remember, Iger was telling us for this part that we created, it was going to be a 4-hour wash time. So we'll go ahead, submerge our part in the solvent. And Iger will tell us when the part has been completed washing. So 4.5 hours has gone by, and we're going to go ahead and remove our part from the wash. At this point, we're going to go ahead and put it in the drying section of the wash station for about 1.5 hours was the recommended dry time. So now that our part is dry for the recommended time, we can go ahead and we'll get our mass after we've washed our part to make sure that we've reached the proper threshold of mass loss. Now, I've done the calculations before we got it out of the wash, and we reached our 4.1% for stainless steel. So I'm going to go ahead now, place our part on the center plate, and place it in the center. We'll go ahead and install our heat shield. And close up our sinter for the run. And now at this point, we can go ahead and start our sinter. So at this point, our sinter has finished sintering our part, and we're going to go ahead and remove it. First, we'll open up our inlet door here. And we'll be careful because the areas around the opening are going to be hot. Remove our heat shield. And remove our center plate with our part. Now we'll remove our parts from the raft. So the best way to remove our part from the raft is to lock it in a vise and give the raft a whack with a hammer. And here's our finished bottle opener.